this assignment, we are given the data about the pure accuracy, and three parameters are given, which is weight, relative density, tensile strength, and the shift, either evening, night, or morning. So after we analyze the three parameters, this is the data we get. We get the weight in numerical form, in tabular form, and from the tabular form, we use the range for the weight, and we determine the frequency distribution for each range of weight, and we plot the data in the graph form, and we can find that the weight between 345 and 355 milligrams has the highest frequency of 59. And we repeat the same step for relative density, the numerical form, the tabular form, and the frequency distribution for the range. And the graph we get that the highest frequency is between the 87 to 88% of relative density. Then we repeat again for the tensile strength, is the numerical form, tabular form for the tensile strength. We use the range to determine the frequency distribution, and we plot the data in graphical form, and we found that the highest frequency for the tensile strength of the tablet produced is between 7.1 to 7.2 megapascal.
Hi, I am Jeremy. For task B, first we group the data using an Excel file in the interval of 10. After that, we use Excel file to plot a histogram. Then we proceed to the chi-square test. We let H0 to be the weights of standard tablets, follow the normal distribution, while H1 to be the weights of standard tablets do not follow the normal distribution. Then we calculate the Z value and P value. To double check our calculation, we calculated the total of frequency to be 200 and the P value to be 1, which means that our calculations are valid. With all the P values, we calculated the values of EI for each group using the formula and multiplied by the probability PI. Then we calculated the values of OI minus EI squared over EI, and their sum was calculated. In conclusion, since EI is greater or equal than 5 for all values of I, 1, 2, 3, 4, 5, and 6, and V equal to K minus P minus 1, where K is 6 and P is 0 because there is no unknown parameter, we get V equal to 5. Using the alpha equal to 0.05 and the degree of freedom of 5, we get chi-square value to be 11.0705. Since the chi-square test value, which is 3.54761, is less than 11.0705, we fail to reject H0. We conclude that the weights of standard tablets produced by the manufacturer follow the distribution.
Hi, I'm Lim Sun Wei from Group C, and now to present my part. For part C, we need to determine whether is there any significant difference between tablet weights mg from the different shifts. So method we are using is one-way ANOVA test using Microsoft Excel. So the purpose is to decide is there any significant difference at 5% between tablet weights from the different shifts. So we are going to have three types of shifts, evening, night, and also morning. So for respectively, we have count, sum, average, and variance calculated using the Excel as a summary. And then for the ANOVA test, we are using single and one way. So the source of variation is between groups, and total, which is the treatment error and total. So for sum of square we have been calculated using Excel, and then for degree of freedom also, and then mean square, the F value, P value, and the F critical. So we accept the null hypothesis if P value is greater than alpha 0.05, and then we reject H not the null hypothesis otherwise. So therefore, in this conclusion, our P value get is 0.8355579, which is greater than the significant level of 0.05. Therefore, we accept null hypothesis H0 and reject H1. And then there is sufficient evidence to show there is no significant difference between tablet weights from the different shape at significant level of 0.05 or 5%. Thank you.
Now, let us talk about part D. From the instruction given, we know that the tablet's tensile strength is related to its relative density, and then we were required to predict the tensile strength when relative density is at 68%, 74.3%, and 80.1%. After that, we need to clarify the validity of the model that being used to carry out this prediction. Since we need to identify the relationship between two objects, thus a simple linear regression model had been used to investigate the relationship between tensile strength and relative density. First, we need to write the hypothesis first. For H0, beta is equal to 0, which means that there is no linear relationship between tensile strength and relative density. While for H1, beta is larger than 0, which means that there exists positive linear relationship between tensile strength and relative density. Based on the simple linear regression that we had performed in Excel from the data given, this is what we had obtained. The Pearson correlation coefficient R is equal to 0.x61062159, which is close to 1. And then the p-value obtained is 4.60078 times 10 power of negative 60, which is much lower than alpha that is equal to 0.05. Hence, both of these values had indicate that there is a strong positive linear relationship between tensile strength and relative density. Thus, we can start to find the simple linear regression model by using the formula y equal to bx plus a. From the data, we have obtained values for a equal to negative 0.50949x695 and b equal to 0.0x69251x3. Thus, the simple linear regression model is y equal to 0.0x69251x3x minus 0.50949x695. This graph is the relative density line fit plot that was plotted based on the data. Those blue dots are the original tensile strength, while the red dots are the predicted tensile strength from our model. Since we had obtained the simple linear regression model, we can substitute relative density with the values 68%, 74.3%, and 80.1% to predict its corresponding tensile strength. Eventually, we had obtained that for 68%, the tensile strength is 5.401425494 megapascal. For 74.3%, the tensile strength is 5.949054147 megapascal. And for 80.1%, the tensile strength is 6.453220208 megapascal. However, this prediction is not valid. This is due to the reason that this simple linear regression model was developed specifically based on the data of relative density with a range from 82.8% until 93.3%. Hence, any value of relative density beyond this range is not suitable to be used in this simple linear regression model. In a nutshell, the prediction from the relative density with the values 68%, 74.3%, and 80.1% by using this simple linear regression model is not valid. That's all from our presentation. Thank you.